Welcome back. So for this lesson, what we're going to look at is when a function actually returns a reference. What do we do with it? How do we handle it? And what are the possibilities? First, let's review quickly what a function, when a function returns a value, right? So let's say we had a function that returns an integer. Let's call that function foo. And let's say it had a local variable int a, and let's give it a value of 0 and somehow return that a back. Okay, so we know we have assigned it 0, so it will return that 0 to whomever calls it, right? So in here, you could have an int b, for example, and you're going to call foo, and what's going to happen is b now will have the value of a, and then you can actually print b equal, and go ahead and do a b and l, and let's see how this behaves, right? So this should be pretty straightforward. Compile and run, and there you have it. So b will be 0 in this case. Just to prove the point, we could change b to 8. Compile and run again, and we will have returned, by changing a to 8, we would have returned an 8 for b. Now, what would happen if I put an ampersand here? Okay, let's see if that fundamentally makes any difference at this stage. So let's compile and run. And notice nothing really happens as far as we're concerned. However, there are a few things we can do. Okay, now b simply has its own address. It has nothing to do with the address of a. And so can we have a pointer, however, that will grab the address returned by foo? Okay, so instead of having simply b, can we have an actual pointer that will grab the address of foo? And then we can dereference that pointer. Well, let's try it. So let's have an int asterisk, and here now I am interested in the address. However, I am going to dereference the pointer here. Notice here, since you're using a pointer notation, you have to dereference it. Now let's see if we get our 8 back. So compile and run, and sure enough, you do get that. Now let's suppose I forgot to put an asterisk for b. So what would I get? Now let's say I forget to do an asterisk here. So let's compile and run. And notice now I get an address. Interesting. Whose address is that? Well, let's go ahead and print the address of a within foo, and let's see if they match. So let's go ahead and do this. Cout local address for a, and we're going to do it here, and that would be an %a. That's the address of a. And let's see what happens when you call foo. Now when you call foo right here, this will execute. So we will see this line first. When this stack is over, we're going to come back to the main stack. Okay, so compile and run, and there you have it. So a has an address of 22FF40. What happened is b now has the address, but we're dereferencing that variable. So now we need to dereference to really make sense of what we're trying to do. So we're passing by reference back. If that's the case, well, then can we modify a remotely? Okay, so here you go. Right, so the local address for a is this, and however, when we come back, we have the value 8 that was stored in it. Let's make this interesting. Let's have the user enter a value for a. So cout enter a value for a, and let's do a cin Okay? All right, so let's go ahead and run this, compile and run. And let's do a 23, for example. And we get our 23 back. So 23 stored in A. A's address is 22FF40. When we return, we are dereferencing that pointer back and we get our 23 back. If that's the case, can I change the value of A remotely using the pointer? The answer is yes, if you make A static, so you can come back and see if that change took hold. So maybe we'll do static. Oops, got to spell static better. And let's give it a value of 0 initially. Okay? And we're going to do this. We're going to say something like this. Cout value of A upon entry in foo. As you enter foo, what is the value of A? The first time it's going to be 0. But since it's static, the next time you come back, it will be a different value. Okay? All right, so that would be A. And let's do an endl here. So compile and run. And notice that the initial entry in foo is 0. I got to put a little space between here and foo. And then it's asking me for a value. So I'm going to do 8. And B is now 8. So we're going to have to prove that that static variable actually works. So I'm going to go ahead and print what foo returns. So we could do something like this. Cout calling foo again. And we're going to call it here, foo. Notice you don't need during and% here, endl. And let's see what happens. Compile and run. Okay, so notice the initial time, it's 0. So I'm going to put a 7 here. Okay? We got a 7 by dereferencing B. But notice what happened when we called foo again. Value upon entry is 7, no longer 0. That is what we mean by static variable A. Great. So I can give it another value to end this program. Okay, so we come back, we're done. Now, because it ran the last foo example here, can we alter the static variable from main? The answer, we can, because we have a pointer. We can actually play with that. And let's do it here. So how can I do that? You could take your asterisk B and let's make it equal to -1. So you know what I'm doing here is overriding whatever value is pointed to by that pointer, and let's call the function again. So cout calling foo one more time, or one last time. So you can tell we're at the end of our presentation here. And let's call foo. And let's see what effect that had by having a pointer now have access to this variable. Because we returned an address, so we had full access to that address. Let's see how that works. Compile and run. Okay. So the first time, let's enter a 10. Okay. So we did have a 10. It displays it. So let's put a 20. Now watch what happens now. We have a -1. It overrode that 20 remotely. Right? So star B equal -1, we're right here now. This is executing this foo right here. This is where the prompt is. Right prior to that, as soon as it got in upon entry, you have a -1. So we were able to alter a local variable within foo remotely from main. That is because we had access to its address. Okay? Now, I don't recommend this style of coding. It can become spaghetti for you. But at least now you see how powerful pointers are and why they can create a lot of confusion as well.